Now, in all the examples, we've been dealing with some closed form, some list form, and some recursive forms. List and recursive forms are very unreliable because you have to calculate all the terms before the term you want before you can get the term you want. Closed form, you don't need to you can get away with just calculating the term that you want. So that's what we're going to do, is find a way to find the closed form for arithmetic and geometric. Because in general, it's not that easy to find a closed form formula. So for arithmetic, remember, we have a common difference, which we will call D. And you add that to each term to get the next term. That's the definition of an arithmetic sequence. So let's just start out with a general sequence. So A1 is equal to A1. We don't know what the first term is. But to get the second term, we add D to that. So A2 equals A1 plus D. Now again, I don't know what that is, but we could calculate it. Then A3 would be A2 plus D. But A2 is already A1 plus D plus D. So again, that's because I'm taking this and plugging it into there. That's why we're getting two D's now. And D plus D is 2D. So then A4 is that. I'm going to skip a step now, but I'm going to just say it's what we just had. So A1 plus 2D plus D, or A1 plus 3D. Let's do one more. So A5 is what we just had plus another D. So we get A1 plus 4D. So hopefully you see, in general, if I just wanted AN, I would just have to take what A1 is, my first term, and add N minus 1 times D. And the reason why it's N minus 1 is because you don't start adding the D until the second term. So that's why it's not N, that's why it's A N minus 1. And that is our formula for the closed form of a arithmetic sequence. Now to get the closed form for a geometric sequence, we're going to start out the same way, except instead of a common difference, we have a common ratio, which we will call R. And again, we're going to start out, I do not know what the first term is, so A1 equals A1. But then I can calculate all the other terms. A2 would equal A1 times R. A3 would equal that times another R. And then R times R is R squared. A4 is that times R. So that's A1 times R cubed. And then just for good measure, A5 is that times R, which is A1 times R to the fourth. So we get that AN is our first term times our common ratio to the N minus 1 power. So now, if you have a recursive or a list sequence and you want to find the 20th term, you can find this closed form first, plug 20 in for n, and you're all set. Well, example 3 isn't going to ask for the 20th term, but you could be asked that in your homework. Example 3 is just asking for the closed form. So the first thing I'm going to notice for this is that if I multiply by 1/10 to each term, we get the next term. And the reason why I recognize that it's multiplying by 1/10 is because the number is getting smaller, so I'm going to multiply by a fraction. And since I'm adding 1 0 in front of the 9 each time, that's 1/10. If, for example, you were adding 2 zeros in front of the 9 each time, that would be 1 over 100. So this is geometric with r equal to 1/10, and a1 is equal to 0.9. So then an is equal to 0.9 times 1/10 to the n minus 1. And there's our sequence. So if it is purely geometric or purely arithmetic, to come up with the closed form is pretty easy. But a lot of times, as you're going to see in B and C, we're going to have not purely arithmetic or not purely geometric. For example, if you want to pause the video, try to see if you can multiply by some number for B or add some number for B. And then you'll notice you can't. So what I'm going to do first is rewrite it though, so that all of the terms are a fraction. And then I'm going to put the negative sign in the denominator of the fraction. So I'm hoping you notice the numerator stays a constant 2. So there's no formula for the numerator. The numerator is just 2. But the denominators, which are 5, 1, -3, and -7, well, that comes from adding -4 each time. So the denominators, which I will call Bn, would be a1, which is 5, plus n minus 1 times d, which is -4. I don't want that to look like -4, so I'll put parentheses around it. So if you distribute this and combine like terms, you get 9 minus 4n. Now this closed form is only for the denominators though. For the original sequence, it's going to be 2 over that. So this is our answer for part B. Now again, if you want to pause the video, see if you can come up with an arithmetic sequence or geometric sequence for part C, go ahead right now. But I'm hoping you'll notice that you can't. Again, I am going to rewrite it, and this time I'm going to put the negative in the top. And a lot of people ask, well, how do you know top or bottom? Well, in reality, there is no given rule. You just try it one way or the other and then see if you can get it to work. So here I know it'll work. So here for the numerators, or the tops, which I'll call T, it's 1, -2, 4, -8, ... And you notice that you're multiplying by -2 each time. So that means for our numerators, we get a closed form of Tn equals 1 times -2 to the n minus 1. Now for the bottoms, or the denominators, we have 1, 7, 13, 19, and so on. And you're adding 6 each time. So you notice that the denominators are arithmetic again. So then Bn would equal 1 plus n minus 1 times 6, which is -5 plus 6n. And then since our original sequence was these two sequences over each other, we get -2 to the n minus 1 all over -5 plus 6n. And that's it for this section. If you have any questions, please email me.